1.4. Our objectives for today are to visualize solutions of systems of linear equations in 3 variables, solve systems of linear equations in 3 variables algebraically, and then solve real-life problems, so story problems. So, you've solved systems of equations before. Systems of equations that you did in algebra were like 2x plus 4y equals 6, and 3x minus 2y equals 9. And you would go through and get opposites and get rid of those. We do the same thing, but we're going to be working with 3 variables. So 3 variables are, in this case, most of them are going to be x, y, and z, but they could be anything. So in the form of ax plus by plus c, z equals d, where a, b, and c are not equal to 0. Because if they're equal to 0, you're down to 2 variables. So a system of 3 linear equations and 3 variables. This would be an example. Okay? We've got 3 equations with 3 variables. And the solution to that is written in the form of an ordered triple, x, y, and z. When you solved before, you would find the values of x and y. And so that was an ordered pair. But now we're going to have 3 answers, so we're going to write it as an ordered triple, x, y, and z. So if we look at page 30 in the text, you can visually see the type of answers that you get. So this is when if you think of your answers in a plane, you can have where you have one plane and they all meet at this one point. And that one point is your ordered triple. You can also have infinitely many solutions where our 3 planes cross and they form a line, so anything on that line would work. Now that doesn't mean, when I say infinite solution, that doesn't mean that everything works. It just means that anything that's on that line would work. And then you can have an example of no solution, because none of the points, like if I was to, where the blue and the green intersect would be on this line right here, and none of those are the same value. And the green and the black intersect on this line, and this one intersects on that line, so none of them have a point where all 3 planes intersect at the same place. You also have one like this, where you have 2 parallel planes. Again, there's no place that all 3 planes intersect. And then you have a case here where none of them intersect. And so those are all different possibilities for answers. You'll either get 1, infinitely many, or none. Are 3 types of solutions we can get as we go through this. So, the steps to solve 3 linear equations and 3 variables. So we'll go through the notes, then we'll go through some examples. So it says, steps to solve 3 linear equations and 3 variables. First thing you want to do, choose a variable to eliminate. So when you choose a variable to eliminate, you can pick any one you want. I try and pick one that they all go into the smallest number possible, because then I stay away from big numbers. But once you choose a variable to eliminate, then you use substitution or elimination method to get to 2 equations with 2 variables. Step 2, solve the system of 2 equations for both variables. So that means we're going to get it down to 2, then it's what you did in Algebra 1. We'll solve that for the whatever 2 variables are left. And then step 3, substitute your answer from step 2 into any of the 3 original equations to solve for the last variable. And then lastly, I always advise checking it, plug in the answers to any of the 2 original equations to see if they work. That way, you don't get an answer, and because you made a small mistake, it's incorrect. So, the other thing that you have is that if there's a possibility that the variables will cancel out. Okay? If all the 3 variables cancel out as you do the problem, if the values left are not equal, so let's say all the x, y's, and z's cancel and I get 3 equals 7, then there's no solution, because there's no way 3 and 7, 3 is equal to 7. If the values left are equal, like we get 4 equals 4, then there are infinite solutions, because then that's where we have that single line where they all intersect, and so there's an infinite number of solutions that work. So these are the steps that you're going to go through, and now let's take a look at some examples and go through it. So again, step one, we're going to choose what variable we want to get rid of. So in this case, I would look at the x's. And the first thing that 2, 4, and 6 all go into is 12. And the first thing that 2, 3, and 1 all go into, again, there's no variable here, so it's considered to be a 1. They'd go into is 6. And the first thing that 3, 5, and 4 all go into would be 60. So in this case, I would choose to get rid of the y's. Okay? So here's how we do it. We're going to eliminate the y's. So that's the variable we're going to get rid of. So what we have to do, I'm going to number these, 1, 2, and 3. And so we have to use 2 of those equations and get rid of the y's. So I'm going to use the first and third one. And I have to get the y's so they're opposites if I want to get rid of that. And so since this is 2, this would have to be negative 2. So I'm going to multiply this equation by positive 2 to get rid of that. So the first equation is going to remain the same. 4x plus 2y plus 3z equals 12. And the third equation, I'm going to multiply this by 2 because I want those y's to be opposite. So 2 times 6 is 12x, 2 times negative 2 is negative 2y, and 2 times 4z is 8z. And then you have to remember to take 2 times everything, so 2 times the negative 3 is negative 6. So, the reason we get opposites is so when we add these two equations together, the y's disappear. So 4x plus 12x is 16x. The y's cancel. 3y plus 8z is 11z. And 12 plus a negative 6 is 6. So now I've got one equation with 2 variables, but I need 2 equations with 2 variables. So now I'm going to, once you've used 1 and 3, you have to use either 1 and 2 or 2 and 3. It doesn't make any difference. It's totally up to you. Okay? If I used 1 and 2, the first thing that 2 and negative 3 go into would be 6. So I'd have to multiply this equation by 3 and this equation by 2. Whereas if I use these two, I only have to multiply the bottom equation. So I'm going to use 2 and 3. All right? And 2 is going to stay the same. So 2x minus 3y plus 5z equals negative 7. And I'm going to multiply the bottom equation this time by negative 3 to get opposites. So I'm going to go negative 3 times this equation. And so negative 3 times 6 is a negative 18x. And a negative 3 times negative 1 is a positive 3y. And a negative 3 times 4 is a negative 12z. And a negative 3 times negative 3 is a positive 9. So again, I've done this again to make the y's opposite. So now I'm going to add those two equations together, so I get 2x minus 18x is negative 16x. The y's again cancel. 5 plus negative 12 is a negative 7z equals negative 7 plus 9 is 2. So now I've gotten down to 2 equations with 2 variables, and this is what you did in Algebra 1. So now we're going to take these two, got these 2 new equations, and I have to make, again, one of those opposites. Well, in this case, the x's are already opposites, so I'm just going to leave the first equation the same, and I'm going to put the negative 16x minus 7z equals 2. Because again, those x's are opposite, I don't need to do anything. And I add those together, so this cancels. 11 minus 7 is 4z, and 6 plus 2 is 8. And then I solve the equation for z. So 4z equals 8, and I get z by dividing by 4. I get z equals 2. So now I know that z equals 2. So now I can take this value and plug it into either one of these equations and solve for x. Doesn't make any difference which one. If I plug it in here, I get 16x. 11 times 2 would be 22. Now I solve for x, subtract 22. 16x equals negative 16. Divide by 16 and we get x equals negative 1. If I would have done it in this one, I would have gotten negative 16x, 2 times negative 7 is a negative 14 equals 2. Add 14 to both sides. And divide by negative 16. And again I get x equals negative 1. So it won't make any difference which one you plug it into to find the answer. Totally up to you. So now we have two of the answers. We know x is negative 1. And we know z is 2. So now we can go to any one of these three equations and plug them in and solve for y. So I'm just going to plug it into the first one. 4 times negative 1 is negative 4 plus 2y. 3 times 2 is 6 equals 12. And then we solve this. So negative 4 plus 6 is 2. And subtract 2. And we get 2y equals negative 6. Excuse me. Positive 10. Negative 2y equals, subtract negative 2, 10, and so y equals 5. And so now we have our ordered triple. Negative 1, 2, and 5, or excuse me, put them in alphabetical order. So negative 1, y is 5, and z is 2. Now here's where I would always, because if you make a small mistake, you're not going to catch it when you do this. So now what we need to do is just check it in. We solve for y in number 1, so we want to use either of these to solve to make sure our answer is right. So we just check it. So I'm just going to check it in this one. So 6 times negative 1 is negative 6, minus y, so minus 5, plus 4 times 2 is 8, and that should equal negative 3. So negative 6 plus minus 5 is a negative 11, and negative 11 plus 8 is negative 3. And so negative 3 equals negative 3, so we know we got it right. So you can see it's quite a process to go through. Take it slowly. The nice thing about this, when you do it on the computer, you can plug it in your first answer and check to make sure you get it right, so you don't do a whole bunch of work wrong. So when you're working on this on the computer, as soon as I got the first one, which was z equals 2, you can type z equals 2 into the ordered triple and check it and see if it's right. So that way you don't make a mistake on the first thing and then do all the rest right and get all the wrong answers. So let's try another one. So now we have this one. So again, we have to choose a variable to get rid of. So if I look at these, the first thing this goes into is 20, the y is going to 5, and the z is going to 15. So I would get rid of the y's. So again, I like to number the equations to keep track of them. So let's use 1 and 3. And the y's are the same, so I'm going to multiply this by a negative 1 to get opposites. So the first equation's remaining the same. The second equation, number 3, I'm going to multiply by negative 1, so negative 4x minus y plus 3z equals 6, and we add those together. So we get negative 3x, the y's cancel, plus 4z equals 8. All right, so we get opposites, we add them together. Now we need to get rid of another one, so I'm going to use 2 and 3. And I'm going to multiply this one by a negative 5 to get opposites. So negative 5 times 4, 2 is going to stay the same. 5x plus 5y plus 5z equals 3. And I'm going to multiply by a negative 5, so negative 20x minus 5y plus 15z equals negative 5 times 6 is 30. And we're going to add those together, and so we get negative 15x, the y's cancel, plus 20z equals 33. So now we have to get opposites. So I'm going to make the x's opposites. So I'm going to multiply this by 5 to get opposites. 5 times negative. Actually, I want a negative 5. So negative 5 times negative 3 is a positive 15x. So those are opposites. Negative 5 times 4 is a negative 20z. And negative 5 times 8 is a negative 40. And now when I add these together, those are opposites, they cancel. These are opposites, so I get 0 equals negative 7. So this is an example where all the variables canceled out and they're not equal, and so the answer is no solution. Another example. So again, here we've got the 3 equations. I'm going to number them. I choose a variable to get rid of. In this case, the first number these would all go into would be 5, 5, and 1. So I'm going to choose to get rid of the z's. Now again, you can choose any one you want. You'll still get the same answer. So let's choose 1 and 2 because they're opposites already. So now, in this case, since they're already opposites, I don't need to multiply either equation by anything. I can just keep them the same. So they're opposites, so we add them together. And I get 2x minus 2y equals negative 6 because the z's cancel. And now I'm going to use 2 and 3 because those are opposites. So I'm going to use 2 and 3. And again, those stay the same. Again, you can't have to use 2 different equations. Combinations. And 5x. So again, the z's are opposites, so I'm going to add those together, and I'm going to get 6x minus 6y. Excuse me, z's cancel. Negative 3 minus 15 would be a negative 18. And so now I'm going to use these 2 equations, and again, I have to get opposites, so I'm going to leave this one the same, and I'm going to make the x's opposite. So I'm going to multiply this one by negative 3. So negative 3 times 2 is a negative 6x, so that's going to go there. Negative 3 times a negative 2y is a positive 6y. And a negative 3 times a negative 6 is a positive 8. Oh, this is a negative 18 up here. Negative 18 up there. And negative 3 times negative 6 is a positive 18. And so when I add those together, opposites cancel, opposites cancel, opposites cancel, so I get 0 equals 0. So this is a case where the variables canceled out and it's equal, and so that would be infinite solutions. So I went through one where we get an answer. So we had our ordered triple here. We did one where they canceled out and they're not equal, so that's no solution. And we did one where they are equal and it's infinite solutions. And those are the 3 types you'll have. So what I'd like you to do now is to go ahead and pause the video and try this problem. And then after you've got it done, come back and I'll show you how I did it. You can check to see if you got the answer right. So on this, if I did this, these would all go into 3. These all go into 2. And these go into 4. So again, if I was to do this, I would probably eliminate the y's first. But again, you can do it in any of them would have worked. So I'm going to number these 1, 2, and 3. 1 and 2 are opposites, so I'm going to use those. This one stays the same. Add the 2 together. So 4x, the y's cancel. In this case, the z's cancel too. So I get 4x equals -4, and so x equals -1. I still need to get rid of the z's, so now I'm going to use 2 and 3. Actually, I'm going to use 1 and 3 because those are opposites. If I did 2 and 3, I'd have to multiply one of those by -1, so I'm going to use 1 and 3. So 1's going to stay the same. And 3 So in this case, the x's cancel, they're opposites. The y's cancel because they're opposites, and so I get 5z equals -20, and so z equals -4. So a little bit different, we didn't end up with 2 equations with 2 variables like we did on the other examples. So now that we've got x and z, we can just plug those back in and solve for y. And again, you can do this in any one. I'm going to take number 1. So -1 minus 2y minus 4 plus z would be -4 equals -11. Combine like terms, we get -5. I'm going to add 5. So -2y equals -6. Divide by -2. And so we get y equals 3. So our ordered triple should be -1, y is 3, z is -4, and so now we just check it in one of these other ones. So I'm going to check it in the bottom one. The opposite of -1 would be 1. Let's change that color. The opposite of -1 would be 1. 2 times 3 would be 6. And 4 times -4 would be -16. So that would be 7 minus 16 would be -9. And so that's equal. So I know I got it right. So it's a long process. And again, as soon as you get one answer, plug it into the computer and check it to make sure it's right before you go on. So because if you make a mistake here, the other answers will be wrong, but you would have done the process right. So you have to be real careful on that. And so your assignment for this one, and again, this will be on the Big Ideas Math, but it's page 34, numbers 3 through 20.